making the boundary whenever a flood used to come or something. So with the help of soils or sands, they used to make the boundary kind like triangular structure. So they were making everything for the survival, but they were not aware about each and every different types of geometrical shape, their names. It was not known to them. Even during the Harappa civilization, we have seen, if you have seen the movie also, that such a well structured city were there, drainage system were there, rectangular pool was there also,
Yeah.
right?
Yeah.
So they were making the shape. Even a rectangular bricks was also there. They were using the bricks to make the houses and buildings, everything. But it was not known to them that okay, this is just a rectangle, it's a square. This was not known to them. They were just
Okay.
using it, and for the purpose of survival, they were making the thing and making it better and better. Now, first time a Greek mathematician whose name was Thales, he came and proved first theorem, that is circle theorem, or theorem which is related to circle. And that theorem says that circle is bisected by its diameter. Circle
Okay.
is bisected by its diameter. First time given by first, like one of the proof given by Greek mathematician Thales.
Okay.
Now from after this era, the scientists started coming. Even when you will go to ancient time, you have seen that in Egypt there used to be a pyramids and all pyramid shape. And even the truncated pyramid, that means the pyramid like this one, like the broken part of the pyramid, I want to say. They used to have a truncated pyramid, like the upper portion is broken. There also they used to know like that how to find the volume, how to find the area of the surface. So till like from that time, when the first Greek mathematician Thales has given the theorem, that is circle is bisected by its diameter, the like the revolution and everything, the invention, discovery, everything just started about the geometry. We are having geometrical shape all around us. If I will show you this shape, it's a like a, if I will show you this shape, it's a cylindrical shape, you can see, right?
Yeah.
Or
Yes.
even if I will show you my cell phone, it's a rectangular shape, you can say, right? So we are having geometrical shapes all around us. Now this Pythagoras was one of the famous student of this Thales only. We have done Pythagoras theorem, right?
Yeah.
So that Pythagoras is the student of this Thales only. Okay. So
Okay.
what exactly we are doing, this chapter is not more about solving the problem. It's more about just understanding what exactly was happening in the past of the geometry. How Euclid came, he started giving the theorems, definitions, postulates. All right.
Yeah.
Now there comes a scientist whose name is Euclides. Now, Euclid has given the definition, axiom, postulates about which we are going to learn in this chapter. What exactly are the definition he has given? What are the postulates he has given? What are the axioms he has given? And the first thing Euclid says, that solids, any solid, are made up of surfaces, and surfaces are made up of lines or curves. and curves are lines and curves are made up of points. So let me show you one example. If I will show you this book, can you see this book? It's a solid
Yes.
shape, right?
Yeah.
It's a
Yeah.
solid, right? And this is made up of surface. Can you see for one of the surface, another surface, one surface here, one surface here, one surface here, right? And one surface
Yes.
here. So this
Yes.
solid is made up of surfaces. This surface, this surface, this surface, this surface, this and this. Now this surface,
Okay.
if I'm talking about only this surface, it's made up of lines. Okay, Euclid said that whenever you will take one line, another line, another line, another line, and when you will bind them together, it will create a surface. The best example of the
Perfect.
surface, have you seen someone making woolen clothes?
Yes. Yes. Yes.
How they take the lines and lines and lines, and then they make a piece of cloth.
Piece of cloth.
With
Yeah.
that piece of cloth, they make something like a cap, right? So
Yes.
that cap is having the volume.
Okay.
First what they do, they take a line, they take a lines, this line woolen lines, they take the thread, they take all the thread, bind together, they make a surface. And now
Surface.
by stitching the surface in any shape, they make the clothes in the shape of cap, in the shape of, so solid means three-dimensional solids.
Three-dimensional solid means?
Three-dimensional shape means any shape which will occupy, which is having its own capacity. Like I'm talking about cap. So in cap, when you will see the cap, you can put something in it, right?
Yes, yes.
Or if I'm showing you the cylinder, cylindrical shape, we can fill it with something, right?
Yes.
So that's called three-dimensional shapes in mathematics, which is having its volume, okay, which can contain something. But if you will take a flat surface, a very flat surface, a page, if you will drop a glass of water in that page, it will flow, right?
Yes.
So that is not solid. Like that is not three-dimensional shape. Solid in physics is different thing. Solid in mathematics is different thing. In physics, solid means what? Whoever is like whatever shape is having a solid structure. That's solid. Okay. Liquid means the liquid consistency. Milk, water, these are liquid. But in mathematics, we say solid to three-dimensional shape. Who can the shape which can occupy something, the shape which is having its own volume, the shape which can contain something, that's solid in mathematics. So Euclid is saying that solid is made up of surfaces. The best example is cap, socks. It is first surface is made, and then our grandmother, our mamas, what they do, they just stitch it to make the socks, they just stitch it to make the cap, and that cap can contain something, right?
Yes.
So that solid is made up of surfaces. Surface is made up of line. You can understand either line or curve. Even if you will start taking this curve, this curve, this curve, this curve, and you will just bind them together, again you will have a surface, right?
Yes.
Right? If this type of solid is there, then it is made up of this type of lines, right? Can you see?
Yes.
So it can be made up of a straight line or curve. Now these curves are made up of points. So these lines are made up of when this point, joined together, just bind it together, we will get a line or a curve. So you can understand from the tree, from the plant, we get seeds, cotton seeds, right?
Yes. Right.
And then the seeds go to like factory, and then they make cotton out of it. With the cotton, the thread is made, right?
Right.
So with a smaller point or particle, line, we are getting the line in the market. Line means woolen threads, right?
Threads.
So now
Yes.
you have to learn the structure. You understood the structure, now you have to learn the structure, that okay, solid is made up of surface is made up of line, and line is made up of points. Okay, without
Yes.
understanding, if you will learn, you will forget. But now you know that point will join together and will make a line or a curve. And line will combine together and will make a surface. And surface will combine together and will make a three-dimensional shape or solid. Right?
Okay. Right.
So, with the help of surface, we can make a solid. You can see if I am having this surface, suppose this is just a piece of paper, suppose,
Okay.
then
Okay.
we can just make it like this. Now it
Yes.
will be a cylindrical shape. Can you see?
Yes.
It can occupy something. If I will cover from here, it's a cylindrical shape. It can occupy something. So with the help of one surface, I made three-dimensional shape. That means solid, right?
Right.
Right. So this type of fill in the blanks is all over there in the exercises. Now you don't even have to memorize it. You just have to understand it and you have to go accordingly. Let's move to the next part. Now let me write the Euclid's definitions. Few definitions which are given in your book. Let me write it one by one. We will be discussing that. So a point is that it's just like a chapter which is related to geometry, and here we are learning about the story of geometry mostly. Okay,
Yes.
so let me write few of them, then we will be discussing one by one.
Okay.
Let's see the definitions. When you will go through the definition, no, Yatika, you will find that such a obvious thing is written over here, that the first definition, let me take another color. Here it says a point is that which has no part. So whenever you will take a very sharp pencil or pen and you will just give a dot, a point, very sharp, okay, I am talking about very sharp pen or pencil you will take and just give a dot. It has no part. Does it have any part? No thickness, no length, no breadth. Nothing is there, right? You
Right.
don't have to make a very big dot so that it will have a like width of its own. No, a very sharp pencil you will take or pen and just give a dot. So it has no part, right, of
Right.
itself. No part means no length, no breadth, no dimension, no measurement is there. If I will try to measure it, I will not be able to measure it. Okay.
Yes.
So that's what the definition says. Do we need to remember it? Do we need to memorize it? That point has a no part. It's obvious, right?
Yes. Yes.
Next one is a line is a breathless length. So when we will draw a line, it has only length. It has no breadth. That means it has no thickness. It has no width of its own, right? Only length is there. And that
Right.
line also, when we are talking about line, we will draw a very sharp line. It has only length, nothing else, right? So
Right.
line has no breadth, or line is a breathless length. So only length without breadth. Again, very obvious thing Euclid has said, this type of fill in the blanks will be there. That dash has no part. So you have to say point has no part, because we are learning about first, we are learning about point, we are learning about surface, we are learning about curve, line, we are learning about solids. So what has no part? Obviously point has no part. Which has no breadth? A straight line has no breadth, right?
Right.
Or a line has no breadth. Now the next definition says the end of line are, just a minute, let me check. The end of line are its points written over there. Yeah. The end of line are points. So what I said, line is made up of point, joined together, and we will get a line, right? A lot of tiny particle, when they will come together, we will get a straight line, right? Or a curve.
Yeah.
So here, the end point, the end of the line are point, the middle of the line are point. It is completely made up of points, right?
Yeah. Right.
So here also, if this type of fill in the blanks will be there, the end of the line are, we must know that the line is made up of point. So end will also be point only, right?
Right.
Now the next definition says a straight line is a line which is evenly with point on itself. Obviously, a straight line is a line which is made up of point on itself, right?
Right.
A straight line is a line which is evenly with point on itself. So a straight line is completely made up of point. That's what the next definition says. So Euclid is saying again same and same thing again and again, right? Previously we have learned about it. Now again, a lot of definition is talking about the same thing, right?
Right.
Now the Euclid's definition says a surface is that which has length and breadth. Surface means what? A flat surface. Okay, a flat surface. It has only length and breadth, right? It can be rectangular surface. It can be any surface, flat surface. It will have only two measurements, length and breadth. Okay.
Yes. Okay.
Now the next definition says the edge of surface a line. Now only we were discussing the surface is made of lines. When we will take line, and when we will just attach them together, we will get a surface, right?
Right.
So surface is made up of line. Now the next definition says the edge of surface are line. Surface is completely made up of line. Edge are also line. Okay. So again, the same thing. Now the last definition says a plane surface is a surface which lie evenly with a straight line on itself. Again, a plane surface, a flat surface is a surface which is made up of a straight line, a lot of a straight line. Even if this sentence is saying it is made up of curved line, that is also true, right?
Right.
Surface can be made up of a straight line, curved line attached together, right?
Right.
So you just have to understand this structure, Yatika, that a
Okay.
straight line or curve is made up of points. Okay.
Okay. Okay.
Once you will get the straight line, now you will combine a lot of straight line or a lot of curve to make a flat surface.
Okay.
Once you will get the surface, now you can make a solid. Okay.
Okay. Okay.
So solid is made up of surfaces.
Okay.
And see the definition. Now your chapter in your exercise, it will be talking about is it a definition or it's a postulate or it's a axiom, how you will identify. So you see the structure of this definitions. The
Okay.
definition is all about point, surface, line, solid, right?
Right.
So whenever you will see such structure, that the fill in the blanks, the true false question, the match the following question, any question, if it is talking about line is made up point and surface is made up of line, solid is made up of surface, you have to understand it's from the definition part. It's not axiom. And now
Okay.
only I will show you the axiom and you will find that how axioms and postulates are different from this one. Okay. So definition is completely talking about point, line, surface, solid. That's it. Got it?
Got it.
Okay. Let's move to the next part. Now we will be doing the axioms.
Yes.
And this was few definitions. Like this, Euclid has given a lot of definition. Okay.
Okay.
So we don't have to focus on that. These are some of the definition related to these only. Fill in the blanks and exercises are there. Okay.
Okay.
Now we are going to discuss about axioms. Now this axioms means something which is certain. We don't have to prove it. Okay, in mathematics we prove a lot of things. Okay, we start proving it by logic and anything. This axiom means what? It every day I will suppose there is no invention, no scientific technology and nothing is there, and we are just waking up and looking in the sky and seeing, okay, sun rises from this direction, sun rises from east direction. Again in the next day we just woke up and we seen, okay, again it is rising from this direction only. Very next day again we just woke up and we are seeing that sun rises from the east direction. Then you will go to your friend and you will say that sun rises from east direction. So your friend will ask that prove me how sun rises from east. So you will say, I don't have to prove it. You just wait. You just very next day, you just go and see by yourself. So that doesn't require proof. Just by observation, you are giving one statement and that statement is true. No need to explain it. No need to do nothing. No need to argue with your friend. Just tell them, go and see tomorrow morning. Okay? Such are called axioms. Where any explanation is not required at all. Just by the observation, scientists have got it. They were solving a lot of different theorems, a lot of different mathematics about different things they were learning. And then they find certain things which is obvious, which is very true. And there is no proof for that because that is certain. Okay?
Okay.
So we will be, that's called axioms.
Axioms.
We will be saying few axioms over here given by Euclid's again.
Okay.
So the first axiom is things which are equal to same thing are equal to one another. See how much obvious it is. Things which are equal to same thing. Suppose we are having one thing X, another thing Y. Okay.
Okay.
Two things we are having X and Y. Two variables we are having X and Y. Now
Yes.
that are equal to the same thing. So here I am saying X value is 2. And I am also saying that Y value is 2. So can we say X is equals to Y?
Yes.
Because both are having same value. Like
Yes.
you and me, you are having $100, I am having $100. So can I say according to the money wise, we are both are having same amount,
Yes.
$100. We both are on the same state, are equal with each other in terms
Hmm.
of amount, right?
Yes. Yes.
So that's what the statement says. Two things which are equal to the same thing are equal with one another, obviously, right?
Right.
Got it?
Yes.
Let's move to the next axiom. Now the next axiom says, if equal are added to equal,
So what question can we like ask according to this definition?
we will go to the exercise and we will see the uh, according to the axiom what questions are given over there. Let me read one question from the exercise. So
Okay.
in the exercise, in the exercise 5.1, if you will see the first part, here we are having, can you see it?
Yes, ma'am.
Here, the first question is which of the following true and false we have to see, right? We have to check
Right.
whether the given statement is true or false, right?
Yes. 1 second, ma'am. I cannot find the exercise.
Yeah, take it out.
Ma'am, I directly have exercise 5. I don't have exercise 1.
Yeah, you can tell your like the first question from your book. No worries.
Okay. So the first question says, so solve the equation x plus 4 is equal to 10 and state Euclid's axiom used.
So x plus 4 is equals to 10, right?
Yeah. Right.
And we have to tell which axiom we are going to use here. Okay, just after a while, we will be just getting back to this question. Okay,
Okay.
let's discuss few axiom and then we will do this question. I am writing it separately.
Okay.
The question was x plus 4 is equals to 10. Now the second axiom says if equal are added to equal, the whole are equal. Now the meaning of this second axiom is, suppose you are having half pizza, okay? You are having half of the pizza, I am having half of the pizza.
Right.
Both are at equal state. Half pizza yours, half pizza mine, okay?
Yes. Yeah.
Now someone came and has given you 1/4 of pizza.
Okay.
And someone came has given the same 1/4 of the pizza to me.
Okay.
So again, we are at same state, right?
Right.
Right? Again, your pizza and my pizza, the quantities are same, right?
Right. Right.
So here, let's read the statement. It says, if equal are added to equal. If something which is already equal, half pizza yours, half pizza mine, okay,
Yes.
are added to equal. Now 1/4 you have taken, 1/4 I have taken. The whole
Yes.
equal. Again, your whole and my whole are equal, right?
Right.
Now, in terms of equation, how we will? Am I audible, Yatika?
Yes, ma'am, you're audible.
Yeah. So let's continue. So suppose in terms of equation, how to understand it? Suppose x is equals to y. Okay.
I cannot see a screen.
Already x, both are
Says it.
equal. Can you see the screen?
Yes, ma'am, now I can see.
Okay, so now I'm saying let's understand it with the help of one equation. So if x is equals to y, okay, now both are already same. X and y both are in the same state, both are already same.
Yes.
Now if you will add and will add 4 over here, still they have to be same, right?
Right.
So that's what this axiom says. If equal are added with something which is already equal, then the result will again be equal.
Equal.
Okay. Similarly, the another axiom. Okay. Similarly, the third axiom says, if equal are subtracted from equal, the whole result are equal. Equal are subtracted from equal, the result are equal, or whole are equal.
Yes.
Here it has written the remainder are equal. That means the result are equal.
Yes.
Now the same example, you are having half pizza. I am having half pizza. You have given 1/4 to your friend. I have given my 1/4 to one of my friend. Still we are on the same state, right?
Yes.
You are having just 1/4 pizza. I am having 1/4 pizza, right?
Right.
Let's do your question now. Here your question is x plus 4 is equals to 10, right?
Right.
Here how we will find x value? What will be x value, Yatika?
X is equal to 10 minus 4, which will be 6.
Which will be 6. But in terms of mathematics, whatever you have done, that is perfect. In terms of mathematics, what exactly we are doing when we are having x plus 4 is equals to 10, then we are thinking that, okay, let's subtract, since we need the value of x, that means on the left hand side, we need only x, right? So here, what we are thinking, that x plus 4 is there. If we will subtract 4 from there, then only x will be remaining on the left. But whatever we are doing on the left hand side, we have to do it on the right hand side also, right?
Right.
Okay. Equation means it's like equilibrium. Already both are in equal state. Whatever you are doing in the left, you have to do on the right. Whatever you are doing on the right, we are bound to do on the left. That's the meaning of this equality sign. Okay.
Okay.
So here 4 minus 4 became 0. We got only x on the left, and on the right we got 6. You also got 6, and by different approach only, I also got 6, right?
Right.
Yeah. Now what exactly we are doing, we are this was x plus 4 is equals to 10. Both side was equal. Even it doesn't look like equal thing or something, like it looks x plus 4 and 10 both are different, but no, equality sign means both are on same page, both are on equal state. Okay, now if we will subtract 4 from here and we'll subtract 4 from there, still they'll be equal. That's the meaning of this equality sign, right? So which axiom we are using? We are using the third axiom, that equal and subtracted from here are equal. Are you getting it?
Yes, ma'am.
So the which axiom is getting used? Euclid's axiom, the third axiom is getting used to find the value of x.
Okay.
Because to solve the equation, we are subtracting. And the axiom which is related to subtraction is the third axiom.
Okay.
The question from your exercise.
If it is known that a plus b is equal to 10, then a plus b minus c equal to 10 minus c, write Euclid's axiom that best.
Can you hear me, Ka?
Yes, ma'am.
What was the question?
The question was, if it is known that a plus b is equal to 10, then a plus b minus c equal to 10 minus c. Write Euclid's axiom that best illustrates this statement.
You tell me which axiom is used over here.
Third axiom. Because
exactly. If equal,
subtracted.
Yeah. If something which is already equal and we are subtracting some same thing from the left and the right, still they are equal. That is the third axiom, right?
Right.
Instead of minus c.
Oh.
Yeah, let's do it here. So if we will be using, if there will be a plus b is equals to 10, and the next line will be a plus b plus c is equals to 10 plus c. Here the second axiom is getting used, right?
Right.
We are adding same thing, still it's same. Just give me a second, no? So are you understanding how to use the axioms?
Yes, ma'am.
Okay, similarly, few more axioms are there. Let's understand the meaning of that so that you can finish this whole exercise by yourself. Okay?
Okay.
So the fourth axiom is things which coincide with one another are equal to one another.
Okay.
Let me write number 5 also. Next one says things which are double of the same thing are equal to one another. Let's discuss this much at first.
Okay.
So here, number 4 says that things which coincide with one another are equal to one another. So
Okay.
here we can take a straight line. Here we can take a straight line. Let's say AB. And here is the point C. So here we can see that AC and BC both are part of the straight line AB, right?
Yes.
Both are getting coincide and making the line AB, right?
Right.
So here, or another example, the best example of it, let's take another example. This one can confuse you.
Okay.
Let's take this one only. Suppose we are having a straight line AB, and here C is the center. All right, C is
All
the
right.
straight line. Okay, so here AC and CB both are coinciding at C, right?
Right.